Hello dear students, myself Dr. Amritpal Singh and you are watching Science for Aspirants. So right from today we are going to start a new series that is for 11th class, and we will discuss the whole physics uh, of this 11th class through this YouTube channel. And today we will start from chapter number 1, that is unit and measurement. So in this video lectures we will try to cover the theory which is related with important topics, and then we will do some numerical problems and some MCQs. So this series is going to be a part of the exam preparation that is related with the JEE. Some of the students who are related with the medical examinations and the NEET examinations. So let us start our lecture. So in this units and measurement, what are fundamental units? So fundamental units, they are independent of any other quantities, and these are the basics units, basic physical quantities from which all the other physical quantities they can be derived. So fundamental quantities are also known as the base quantities. So there are three fundamental physical parameters, that is mass, length and time, and based on these three fundamental quantities we will derive all the other derived physical parameters. And derived quantities, these are derived from fundamental quantities, and its example is area, like area of square is length square. So here length is the fundamental quantity, while the area which can be derived from this fundamental quantity, that is known as the derived quantity. Similarly, velocity is equal to meter per second. Here meter, that is the unit of length, and second, that is the unit of time. So both this length and time, they are fundamental quantities, and the velocity, it is derived from these fundamental quantity. Therefore velocity is a derived quantity, derived physical quantity. So similarly, from these fundamental quantities we can derive various physical units, and to represent these units we will use the SI system of units. So SI system is the standard international system of unit, so which is used to represent the unit of any physical quantity. So like you can see in this table, there are 7 fundamental physical quantities and their unit is also mentioned, like length, which is our basic physical quantity, and its unit is meter, and it is represented with small m. Mass, that is again a fundamental quantity whose unit is kilogram, and it is represented with small kg. Time, that is its SI unit is second and represented with small s. So similarly, temperature, again its unit is Kelvin, and it is represented with capital K. So here I would like to represent those symbols whose unit they are started with the scientist's name, whose symbol can be kept as capitalized. So here Kelvin, whose unit is written in capital because Kelvin, its unit is originated from the name of the scientist. Similarly, electric current, whose SI unit is ampere, again ampere is the name of the scientist who derived or who discovered this current, and its unit is capital A. Luminous intensity, whose unit is candela, and it is represented with symbol CD, and amount of substance which we generally study in chemistry, it is represented with 1 mole and whose unit is mol. So these all 7 fundamental quantities you need to remember, and once you remember these physical quantities, you can derive any physical quantity from these 7 fundamental quantities. So there are 2 supplementary quantities, that is plane angle and solid angle. The unit of plane angle is radian and it is represented with RAD, and the solid angle, its unit is steradian and it is represented with SR. So what are the basic rules while writing these unit or symbol of these physical or derived quantities? Now in writing the unit of any quantities, small letter must be used for symbols. So we always write the symbol of any unit in small letter. For example, we use M for meter, m per second, that is for meter per second, that is the unit of velocity. So symbols are not followed by any full stop. So while writing any units, we do not mark a full stop. For example, if I want to write, so I have a rod whose length is 10 meter. So this is how I can write. So I do not have to make a full stop after this. So third is, if any unit it is named after a scientist, its initial letter of a symbol is to be capital. So for example, a Newton, which is the unit of force, and I represent this symbol of N as capital. Similarly, watt is discovered from the famous scientist Watt, and I write the unit of this power watt as capital W. Similarly, Kelvin is the unit of temperature and I write it as K capital. Although the name of the scientist, it should be written in small letters. So for example, if I write a units of force as 5 Newton, I can write it the symbol as N capital, or I can write it, if I want to write it the full name, that is the name of the scientist, then I will write it as 5 Newton with small m. So symbols do not have any plural form, so they are generally kept in singular form. So these are some of the practical units which we will use in our coming lectures. So here 1 Fermi, it is represented as 10 is to power minus 15 meter. 1 nanometer, that is equal to 10 is to power minus 9 meter. 1 light year, that is the unit of distance, which is equal to 9.46 into 10 is to power 15 meter. 1 parsec, again it is unit of distance, that is equal to 3.03 into 10 is to power 18 meter, and so and so. So you can go through these notes. I will also share through our Telegram channel, and you can get all the PDF of these lectures through our Telegram channel. So these are some of the definitions of the standard international units. So the 7 fundamental physical quantities. So definition, you can have a look. You do not need to remember each of them. So you have the good understanding of this, that is sufficient from exam point of view. So the 2 supplementary units, that is the radian and steradian, how we can define those 2 supplementary units. So 1 radian is the angle subtended at the center of circle by an arc equal in length to the radius of the circle. So suppose I have this origin O of the circle, and this is making a angle theta, that is known as the radian angle, and it should be equal to the arc. So here arc is this point AB distance, that is known as arc, and the distance of arc, it should be equal to the radius OA. So this is the radius of the circle, and this is, if I draw it whole, so it will be something like a full circle, and this is arc is the part of this circle, and from that 1 radian is equal to arc over radius, and this theta, that is generally equal to 1 radian. So next is steradian. So steradian is the solid angle subtended at the center of sphere by a surface of this sphere equal in area to that of sphere. So this is the solid angle which is represented with omega, and this is equal to the surface area of this sphere, that is equal to r square, and the radius square, that is equal to again r square. So 1 omega is equal to surface area over the radius of sphere. So there are some other important definitions which you need to remember from competition point of view. So light year, what is light year? So it is the distance traveled by light in vacuum in 1 year. So because it is the distance, so distance, it is generally represented in meter in SI unit. So 1 light year will be equal to distance is equal to speed into time. So speed of light is 3 into 10 is to power 8 meter per second, and 1 year, that is equal to 365 days, and when we multiply it with 24 hours and then we convert it into seconds, so 1 light year, it comes out to be equal to 9.46 into 10 is to power 15 meter. So this much distance a light covers in 1 year, and it is represented with light year. So sometimes there is a question because the name, it suggests light year, but it is the unit of distance. So year, it symbolizes that maybe it is the unit of second, but don't get confused. So light year, it is a unit of distance. So I will write it here. So second is astronomical unit, and it is represented with AU. So it is the average distance of Earth from Sun, and this is equal to 1.496 into 10 is to power 11 meter. So another important unit is parsec. Again, parsec, it is a unit of distance, and it is defined as the distance at which an arc of length 1 astronomical unit subtends an angle of 1 second of arc. So suppose this is a sun, this is earth, and they are subtending an angle of theta, that is of 1 second, through this arc. So here theta, that is the unit of radian, and it is equal to L. This is our arc and this is our radius. So L upon R, that will be equal to, from this one we can calculate 1 parsec, that R will be equal to L. So L is 1 astronomical unit, and radian, it is given here 1 second, and we can convert it into radian, that will be equal to pi over 180. So when we solve this, so 1 parsec is equal to 3.26 light year. So 1 parsec, that is equal to 3.26 light year. Now, what are the advantages of this SI system of unit? So SI system is a coherent system of unit. So coherent system of unit means, So all the derived units, they can be obtained by simple multiplication or division of this fundamental units. So all the derived unit, it is very easy to derive from the fundamental physical quantities, so without any numerical error. So that is why we use SI system of units throughout our this physics. Second is SI is rational system of unit. It uses only one unit for a given physical quantity. So all forms of energy, they are measured in terms of joule. Now there are various type of energies, like you can say kinetic energy, potential energy, heat energy, mechanical energies, and all these energies, they generally explained through one system of unit, so that is in joules, and energy in calories, and so and so. So SI is a absolute system of unit. It does not use any gravitational or any other standard physical parameters to explain any quantities, and it is accepted internationally all across this globe. So either you are discussing physics in India or you are discussing physics in USA or in Europe, so all these fundamental and the derived SI unit, they are equally considered valid. So next is dimensions of a physical quantity. Now if we know the physical quantity unit, and from that we can easily find out the dimensions of any physical quantity. So these are the seven fundamental units which we have talked about, and how we can explain the dimensions of these fundamental quantities. So like length, which is measured in meter, and its dimension we generally write in this form, capital L. Mass, it is measured in kilogram, and it is written as capital L. Time, that is measured in second, and it is denoted as capital T. Temperature, whose dimensional formula is capital K, which is representing Kelvin. Electric current, whose standard unit is ampere, and its dimensional formula is capital A. Luminous intensity, who is measured in candela, and whose dimensional formula is CD. And similarly the amount of substance is known as dimensional formula as mole, MOL. So these are some of the examples of these derived physical quantities and their dimensional formulas. So we will discuss few of them. So let us take the example of force. Now force we will discuss in our next unit, that is Newton's law of motion, which is representing force, which is equal to mass into acceleration. So here mass into acceleration, and its unit is Newton, and we can derive its dimensional formula as mlt the power minus 2. So here mass, it is represented as m, and acceleration due to gravity, which is represented as meter per second square. So meter dimension is L, and second square is t square. So when we solve this, so we can write it as mlt raised to power minus 2. So similarly work dimensional formula we can derive. So work is force into displacement. So dimensional formula of force which we have derived, which is equal to mlt raised to power minus 2, and displacement, it is generally represented as L. So the dimensional formula of work becomes ml square t raised to power minus of 2. And similarly you can derive the dimensional formula of pressure. So pressure is force per unit area. So force is mlt raised to power minus 2 and area is L square. So when we solve this, so the dimensional formula of pressure is ml inverse T raised to power minus 2. So similarly, if you know the value of any physical derived quantities and you know the formula of those physical quantities, and from that formula it is very easy to derive the dimension of that particular formula. So there are some examples which is given, and you can go through each example, and with this practice, once you learn the formula of each physical quantity, then from that quantities you can calculate the dimensional formula of any physical quantity. Now, what are the basic uses of these dimensions? Now, the basic uses of the dimension is we can easily convert from one system of unit to another system of unit. So, for example, if I want to convert a unit from SI system to CGS system of unit, or from CGS to FKS system of unit, and with the help of this dimensional formula, I can easily convert one system of unit into another system of unit without any numerical error. And with this dimensional formula, I can also again check the correctness of any physical relation, whether any given physical relation is correct or incorrect, that I can calculate by finding out the dimensions. So next is driving the relation among the physical quantities, कि किसी भी फिजिकल क्वांटिटी का जो रिलेशन ड्राइव करना है वो हम इजीली ड्राइव कर सकते हैं. So we can easily derive the relation of any physical quantities. So let us say there is one physical quantity x, it is given, and it is dependent upon these three quantities P, Q and R, and using the relation x, which is equal to k is a dimensionless constant, it can has any value, and P raised to power a, Q raised to power b and R raised to power c. So similarly, from this we can find out the dimension or the formula of this x. We can find out the formula of x using this relation. There are some limitations of dimensional analysis. So what are these limitations? So this method does not give any information about the constant k. Now this constant k, it can have any dimensionless physical parameter, and with the help of these dimensions we cannot find the value of this constant k. So second is, it fails to derive the relation if any quantities depend on more than fundamental quantities. Now since we know that there are 7 fundamental quantities, now if any physical parameter which is dependent upon more than fundamental quantities, so then we cannot use this formula. Suppose here using this Bernoulli's equation, the height of this capillary rise h, that is equal to 2t cos theta upon r into density into g. Now here h depends on 4 quantities of mechanics. It depends upon t, it depends upon angle, it depends upon g, it depends upon density. Now density, again, it is a derived unit. So here we can only use the quantities which are fundamental quantities. So here there are some quantities which are derived quantities, so it is not possible to find the dimensions of this h using this formula. So similarly, it also failed to derive these relation, because in this relation motion equation s is equal to ut plus half at square, you can see that here a, that is acceleration, again acceleration, it is a derived quantity, so we cannot derive these equation. Next is order of magnitude. Now how we can find the order of a magnitude? Now the order of magnitude, it can be find out using this closest equation, that is from 0.5 n to 5. Now suppose I have a equation 2.75 into 10 is to power 12. Now here this is my n. Now first I will put the value of this n in this equation and see n should be between 0.5 to 5, and if it is satisfying, then the order of magnitude of this equation is 12. So we will do some numerical related to this in our next slide. So before doing that, let us discuss about the significant figures. Now significant figure, there are 3 or 4 points which you need to remember. First is all the non-zero digits are significant. So except 0, any number from 1 to 9, it is significant. All 0 between non-zero digits are significant. So here for example we have a example 2.005. so here the zeros are between these two non-significant or two non-zero digits, so it is considered as significant. So it has 4 significant figure. Second point is the 0 on the right of the decimal point but left of the first non-zero digit are not significant. So here for example we have a example 0.002500. Now in this case the 0 on the right of the decimal point ਤੋਂ right side ਦੇ ਉੱਤੇ ਜਿੰਨੀਆਂ ਵੀ zeros ਆ, but before the first non-zero. So here our non-zero digit starts and after that all these are considered as significant and these are considered as non-significant. So in this case 0.0002500, it has 4 significant figures. And what are those 4 significant figure? That is 2500. Third is the trailing zeros in a number without a decimal point are not significant. So ਜੇ ਕਿਸੇ ਵੀ ਨੰਬਰ ਦੇ ਵਿੱਚ ਜਿੱਥੇ ਕੋਈ ਵੀ ਡੈਸੀਮਲ ਪੁਆਇੰਟ ਨਹੀਂ ਹੈ, ਸੋ ਉਹਦੇ ਵਿੱਚ ਜਿੰਨੀਆਂ ਵੀ ਟ੍ਰੇਲਿੰਗ ਜ਼ੀਰੋਜ਼ ਹੈਗੀਆਂ ਆ ਸਿਗਨੀਫੀਕੈਂਟ ਫਿਗਰ ਤੋਂ ਬਾਅਦ, ਉਹਨਾਂ ਨੂੰ ਆਪਾਂ ਕੰਸੀਡਰ ਨਹੀਂ ਕਰਦੇ. ਸੋ ਫਾਰ ਐਗਜ਼ਾਮਪਲ ਇਨ ਦਿਸ ਐਗਜ਼ਾਮਪਲ 2500 ਔਰ 2500 ਦੇ ਵਿੱਚ these two digits, 2 zeros, they are not significant. So it is considered as having 2 significant figures only. Next is in addition or subtraction or multiplication, The final result should have as many decimal places as are there in the number with the least decimal places. ਹੁਣ ਜੀ ਆਪਾਂ ਕੋਈ ਦੋ significant figures ਜਿਹਦੇ ਵਿੱਚ ਆਪਾਂ addition ਕਰ ਰਹੇ ਹਾਂ ਜਾਂ subtraction ਕਰ ਰਹੇ ਹਾਂ ਤੇ ਜਿਹੜਾ ਸਾਡਾ final result ਆਏਗਾ ਉਹਦੇ ਵਿੱਚ ਉਨੀਆਂ ਹੀ significant figures ਹੋਣਗੀਆਂ ਜਿੰਨੀਆਂ ਜਿਹੜੀਆਂ ਉੱਪਰਲੀ ਰਕਮ ਦੇ ਵਿੱਚੋਂ ਜਿਹਦੇ ਚ ਘੱਟ significant figures ਹਾਂ. So for example, if we do a sum of 2.50 and 4.2750, so let us do here. So if I do a sum of 2.50 plus 4.275, so here in the upper I have 3 significant figure, in the second term I have 4 significant figure, and their resultant is 6.775. Now my answer, it should be equal to the digit which is having least significant
alert
figure.
from low battery.
So ਮੇਰੇ ਕੋਲ ਜਿਹੜਾ ਆਨਸਰ ਆਏਗਾ ਉਹ ਵਾਲਾ ਆਏਗਾ ਜਿਹਦੀਆਂ 3 significant figure ਹੈ. So ਇਹਨੂੰ ਮੈਂ 3 significant figure ਦੇ ਵਿੱਚ, since I know that if the last digit is greater than 5, then I can write it as by increasing one term. So my answer will be 6.78, that is having 3 significant figures. So last rule for significant figure is, in multiplication or division, the final result should have as many significant figure as are the figure least significant in any number. So for example, if I take the multiplication of 1.25 into 2.0 and my answer is 2.50, but here in the multiplication for 2.0, which is 2 significant figure, so my answer will be of 2 significant figure, so my answer will be equal to 2.5. So this is all about for today's lecture. So in the second lecture we will discuss these examples, and then we will solve the numericals related to this theory part which we have discussed. So till then, goodbye, see you in the next lecture.